So hello and welcome friends to our channel Intro Mech, where we discuss about basic mechanical engineering concepts and many other things which are related to industrial automation field. So guys, we have started our series which is related to industrial robots, and in our previous sessions we learned about the basics of robots, what are the different terminologies involved in the robots, what are the different configurations of the robot, then what are joints, links, the motions, everything we learn. Now we have come to the end of the series. So one of the most important part is end of arm tooling, because even if you select the robot, the main function is of EOT only unless and until you design the proper end of arm tooling or end effector. uh, we cannot effectively utilize the robot in our automation system. So we'll see what is EOET, how we can design, what are the different steps. So without wasting time, let's get started. So first thing, what is the EOIT or end of arm tooling, which is also called as end effector. So you can see over here at the end of the robot, which is also called as the wrist. So we have the faceplates, some mounting hardware, and then the main end of arm tooling. So this all combinedly make the end of arm tooling. So it will be having different mounting plates, sensors, and many other things. So what are the types of end of arm tooling? Those can be grippers. So grippers are like most common end of arm toolings which are used to pick and place, hold, or manipulate the objects. Then we have material removal tools, so that will include like drills or grinders depending on the application. Then we have material deposition tools. So specialized UAT enables robots to apply materials such as adhesive sealant. So they will have the sealant guns which are attached to the wrist with the help of some sensors and mounting plates. Then we have vision guided tools. In some of the applications we need to visually inspect the parameters are in the system. So let's say we have a conveyor and part is coming on to the conveyor, so we need to check whether the part is okay or not. So we should have a vision system on the robot, so that will be attached to the wrist and is nothing but a end of arm tooling. And then we have custom and multifunctional tools. Depending on the application, we can customize the end of arm tooling. So what is the selection parameters? Now, whenever we think of end of arm tooling or whenever we design the end of arm tooling, some parameters are required to be considered, and those are very important, like task type, what is the object characteristics, process parameters, robot payload, reach, environmental conditions, safety conditions. So what are the key considerations? First is like machine interface. So the end of arm tooling must seamlessly integrate the robotic machine to which it is attached while maintaining the flexibility of the movement. So whenever we attach some end of arm tooling, it should not hamper the flexibility. The end of arm tooling should not interfere with the movements. Then the product interface must account for variability in size, flexibility, surface structure, porosity, then contamination. So whenever we design the end of arm tooling, it will have the direct contact with, let's say, the product. So we need to take care that it should not damage, or at the same time it should accommodate the variations in the sizes. So according to that, we might need to have change your end of arm toolings or something that can accommodate different sizes. Then comes the production rates. So if the production rate is too high, the end of arm tooling operation should also be high. The cycle time will matter a lot. So depending on that, we need to consider whether we are going to pick like a number of parts simultaneously, or whatever end of arm tooling we are designing, what are the actuation rates, what are the actuation times. Then comes the machine learning and programming. So the critical aspect in design, because with the design of end of arm tooling, how it will move into the space, that is very important. Then machine limitations, so definitely like payload capacity of the robo, then CG, of the mass, because we cannot have something, let's say we are designing some end of arm tooling and it is having a two cantilever to the wrist, then it will create the excessive moment, so we need to take care of the CG also. Then the safety considerations, of course, as the robot will be moving inside the stations and it will be holding, gripping the part, there are chances that it may fall down, so we need to take care of the safety considerations. So what are the general design guidelines? So first step is define the application. So whenever we have to design the end of arm tooling, first is what is the robot doing? That means what is the application, whether it is a pick and place, packaging, welding, palletizing, etc. Then the type of object handled, which type of material we are handling, what is its material, its weight, its size, whether it's like a fragile, let's say if it's a glass, then it is fragile. So these parameters should be considered. And then the environment, in which type of environment we are designing the end of arm tooling, whether it's a clean room, it's a industrial, it's a food safe, because depending on that the material will matter a lot. Then the second step is choose the EOT type. So whatever type we just learned, those can be like grippers. In grippers we have different type of grippers, parallel, angular. Then we have suction cups, vacuum suction cups. Then we have magnetic grippers or specialized tools. So depending on the application and whatever factors we just discussed, we need to choose the proper end of arm tooling. Then the materials, so lightweight yet strong, so we need to check out the materials. We at the same time we need to check the wear resistance and corrosion resistance depending on the environment, because it might happen that the robot is operating, let's say in some operation where there are chemical vapors, so it may corrode the material of end of arm tooling. So that's why we need to check the materials. At the same time we need to check its weight, because it will directly go onto the wrist, and we need to check the payload, so that will get added into the payload capacity of the robot. Then comes the design key components. So if we if we think what is the application, then we choose the UAT, then we select the material, then comes the main part, like how to design, how to mount the EOIT, uh, what will be the size of the mounting plate, then what will be its shape, then the gripping mechanism, actuation, whether it is having pneumatic, electric or hydraulic, because on that basis we need to have the routing of the pneumatic tubes, electrical tubes. Then the sensors, what are the necessary sensors required in our application, in our end of arm tooling. And then the of course compliance mechanisms, because there might be slight misalignments, and in order to accommodate those alignments we need to have some compliance devices, or we need to have some arrangements in the design. So these are the design key components. And then we need to take care of the design, we need to add some holes and dowels and slots for the precision purpose. And then uh, we need to check of course the load calculations, as we are discussing the wrist will be having some moment constraints, some payload constraints, so we should check those constraints. And there are different robot softwares in which we can check these parameters also, if we want to check it in depth, because along with these parameters some dynamic parameters are also there, as the EOIT will be moving at a very high speed, so the inertia will come into picture, so all those parameters are also required to be taken into consideration. So let's design, or let's some have a brainstorming on one case study. Let's say we have to design a pick and place, we have to design the EOIT for pick and place application in packaging industry. So what is the objective, is to design an end of arm tooling for robotic arm to pick up lightweight snack packets and having a high production rate from a conveyor and then place them into the box. So the application will look like something that is what mentioned in the image. So this is application of what are the requirements over here. We have to handle the soft and flexible snack packets, so those are non-rigid. So this thing we need to keep into mind. We cannot apply much force on those packets, then there should not be any damage during handling the high speed. So we need to pick 30 packets per minute. The tool should be lightweight and it should be easy to maintain and clean, as it's a food industry. So it should not contaminate, or it should not come in contact with the packets, and it should not contaminate the food. So those things are required to be taken into consideration. So what options we have, the best possible option, you can just pause the video, just think about it. What are the different options or how you can do this? So the best possible way is with the vacuum gripper. Why? The reason is the vacuum grippers are ideal for non-rigid and lightweight objects, because they will not apply huge pressure and they will be having inbuilt compliance, so that they will not cause any damage to the product. Then definitely they will handle the packets gently, and fast actuation speeds they have. So that's why we can have the vacuum grippers. So what will be the design features? So definitely we need to choose the suction cups, and those will be like food grade silicone cups with soft edges for flexible packets. So whenever we design or whenever we pick select the suction cups from, let's say, Festo or SMC, we need to check these things. What is the material of the suction cup? So this is how the design is done. We need to take into consideration all these small parameters. Then of course the vacuum generator, uh, the vacuum generator will also be having different circuits. Then the mounting plate, how we can mount the things onto the robot wrist. So we can have the aluminum material and a lightweight flange that will attach the cups and generator, and definitely the sensors. Now we can have a separate pressure sensor to detect the vacuum, so that it will give the sensor, it will give the output, like, let's say, whenever it will pick the part, the vacuum will be generated, and when it release the vacuum, then another signal is generated that will indicate that the packet has been placed into the box. Or else there are options in the vacuum generator. So in the vacuum generator only we can have the inbuilt sensor, that the output of that sensor we can take into consideration. And then the quick connects, as it is required for quick cleaning and maintenance, so we can use some quick connects with which we can easily remove the end of arm tooling. Now here we do not require the compliance, because if you observe the requirement, we have to just pick and place the packets. So it will not have any specific, let's say, location point, some locating pin, and we need to, you know, enter into that locating pin and precisely hold that pin. We just have to grab the packet and need to place into the box. Again, it's a random box. We don't have to like place that part precisely on some, let's say, pallet, which will be having some precise holes. So that's how we will not require a compensator over here. It will be just simple mounting plate with the suction cups and a vacuum generator. That is all we need for this application. So this is what we have. Bags of chips we can place using pneumatic suction cups. So it will be a simply pneumatic cups, and this will comprise a end of arm tooling. So this is all about basics of end of arm tooling, how we can think, and what are the parameters we need to consider. So if you have any doubts, please do write into the comment section and we can discuss over there. Until then, keep intro making. Thank you for the patient listening. Thank you.